Thank you. Hello everyone, my name is Professor Marion Mouldsby, and I will be your guide on this journey to the development of the concept you all know as, mole concept. Our story starts sometime after the Big Bang with two ancient guys.
Santa Claus? Is that you? Oh wait, it's just you, Aristotle. By the way, what you were saying about splitting matter in half forever just doesn't make sense. There must be some tiny indivisible part. I like to call it atomos.
Nah, it could definitely be broken down, Democritus, and I'm sure for many years beyond, our posterity will believe me and not you.
You're wrong. You cannot just split matter indefinitely. Wait a minute. If you're already alive, shouldn't I be...
Thank you. And thus the theory of atoms was born. Unfortunately, for hundreds of years, people believed Aristotle's continuum theory, while very few even considered Democritus's theory of atomos. Our story continues with Robert Boyle, a man whose experiments brought about both the idea of the title of elements, as well as a useful and well-known law used later to create the basis of the mole concept. Let's watch.
Elements, they must be elements. When you cannot break the substance down anymore, it must be the elementary substance. It's elementary, my dear Watson.
Robert, the elements are earth, air, water, and fire. Just like the Greeks said. They even have a song about it.
There's earth and air and fire and water.
You know what? I'm going to write a book on this. I'll prove my theory right if it's the last thing I do.
And by the way, my name is Wilson, not Watson.
I don't care.
Oh, hello. Well, continuing with our story. This is not the contribution that Boyle is most known for. In fact, Torricelli, another famous scientist, was a major inspiration to the law that helped Boyle get on the map and helped to create a basic understanding for the mole concept.
So basically, I'm creating a barometer. It's a way to measure pressure in units of torr.
Why would you name something after yourself? Egotistical much? Wait, I think I figured something out. I need to record this data.
What's your big epiphany?
Shh, let me think. Did you ever realize that pressure decreases as the gas volume increases?
What?
Seriously, look at this.
You may be onto something.
But what should I name this new law? I could just do what you did and name it after myself.
And thus Boyle's law was discovered. Joseph Priestley, an English chemist, is a man who, among many other discoveries and contributions, is credited with the isolation in its gaseous state of oxygen and discovering oxygen, or in his words, dephlogisticated air, as well as other types of airs.
I'm bored. Let's do something.
Well, we can always burn stuff.
But stuff doesn't burn in the air that well. If only we had some better air.
Well, if you have a problem with how we do things now, why don't you find a better way?
You know what? I will. Eureka! I found it. Haha.
Found what?
Found dephlogisticated air.
Dephlogisticated air? What is that?
The best kind of air to burn stuff with. I told you I could. Ha 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 ha.
Following that, French nobleman Antoine Lavoisier took this general idea of the law of constant composition and created the law of the conservation of mass, as well as naming oxygen and hydrogen, and being an opposer of the phlogiston theory. Enter Lavoisier.
Wait, so if I react 2 grams of hydrogen and 16 grams of oxygen, how many grams of H2O will I get?
18 grams, obviously. Just like in every other experiment, we always have the same mass of both reactants and products. I think I'm onto something.
So then it's always the same?
Yes, mass is always conserved. The real question is, what do we name this law in which there is a conservation of mass?
What about the law of mass being conserved throughout any given closed experiment?
Or the law of conservation of mass?
Brilliant.
Next in our story comes the discoveries involving mass. Joseph Proust, a French chemist, discovered the law of definite proportions, also known as the law of constant composition. Hey, these compounds, when they're combined, they always combine in the same ratio. The masses are always the same.
What does that mean?
If you take that mass and the masses of the elements that form the compound, you can clearly see that the masses are proportional. And these proportions don't change no matter by what means I combine them, artificially or naturally. After all this time, somebody finally connected all these different men and their experimental results by resurrecting the idea originally proposed by Democritus. John Dalton was able to create an explanation for the results, as well as inviting others to test his atomic theory and use it to create useful tools for modern chemistry. Most notably, Joseph Gay-Lussac and Lorenzo Romano Amadeo Carlo Avogadro.
So, after observing all the previous scientific experiments, I've got my own theory. I think Democritus was right. It's the only way to explain all this stuff. There is tiny individual parts of matter called an atom. I've created an atomic theory.
That makes sense, but...
Do you have any evidence? That's really all that matters.
Well, I've looked at a bunch of experiments that were done, and they prove it.
Wow, I'm going to need to prove it for myself. I don't trust you.
Okay, then please help me prove it. I am almost positive I'm right.
Dalton's newly created atomic theory stated that elements are made of tiny particles called atoms that are indivisible. The atoms of a given element are different from any other element. All atoms of a given element have identical masses. Atoms of one element can combine with atoms of other elements to form compounds, and compounds always have the same relative numbers of types of atoms. The law of definite proportions. And finally, atoms cannot be created, divided, nor destroyed by any chemical process. Reactions only change the way they're grouped together. Although there are some incorrect points in Dalton's theory, it is generally incredibly correct. Although one point that Dalton had was an idea that elements only combined in single ratios, and that compounds were binary. So, he believed that the formula for water was OH, and that the formula for ammonia was NH. These few mistakes were what caused his theory generally to be not accepted in his time.
Dalton, I may have just come up with something, but I'm not sure if it'll help your theory.
Just spit it out already.
Well, I've discovered that the pressure of a gas is directionally proportional with the temperature. Oh, and the volume of the reactants and products tend to be in whole number ratios. I call it the law of combining volumes. Sometimes I call it Gay-Lussac's law, too.
What? Well, that couldn't be true. It would mean that part of my theory is incorrect, and John Dalton is never incorrect.
Sucks to be you, man.
Actually, Dalton was not completely incorrect. His theory was just incomplete in a way. And with the discovery of Gay-Lussac's law, the road to the discovery of diatomic atoms was made. The next to help on this road was Lorenzo Romano Amadeo Carlo Avogadro.
So Dalton's totally flipped about the whole combining volumes things. He just does not like to be wrong. The dude's got some issues.
Should I tell him what I found then?
What did you find?
Well, based on your experiment, I ran some tests, and I think I found that volume is proportionate to the number of molecules if temperature and pressure are constant. Thus, it could be used to find the number of molecules, and it also shows that the same amount of molecules in a specific temperature and volume and pressure are the same.
What are molecules?
It's a word for atoms when they're all stuck together. I coined it. Do you like it?
Yeah, sure. Well, that's great. That helps all three of us.
And so, the idea that eventually morphed itself into mole theory was born. Since mole concept is based on Avogadro's idea that in a set volume, all gases have the same number of molecules, quantitative analysis of gases became all the more possible, and once discovered, Avogadro's number was named in his honor. Okay, we're good.
Hey Dalton, if you take the evidence Gay-Lussac found, you find that the relationship between the masses of the same volume of different gases corresponds to the relationship between their respective molecular weight.
So, are you proving me wrong at all?
No, but this has the potential to reform part of your theory.
So therefore I'm still correct.
Well, yeah, I guess.
That's all I wanted. Dalton out!
And with that, Dalton's theory began the changes that turned it into modern atomic theory, which helped to develop what is known as mole concept. Ludwig Boltzmann, an Austrian physicist and philosopher, discovered more about gas pressure and how it works.
Hey, Hagrid.
Should I even try with you anymore?
No, you really shouldn't. Anyway, what did you call me in for?
Well, I've been doing some experiments and general work with gas pressure, and I believe that I've figured out that the pressure of a gas is due to the individual particles colliding with the sides of its container.
I guess that makes sense. But why would you do experiments when you can just use magic?
Anyway, I've created a theory that I call gas kinetic theory, that states the pressure of a gas comes from the individual particles constantly moving. So, all the little molecules and atoms are pushing the container and making pressure.
Genius!
Thanks.
Goodbye.
Where are you going? Is Dumbledore calling you?
Done. And with that, the major points that make up the modern mole concept were complete, and the path was paved for Stanislao Cannizzaro, an Italian chemist who was influential in the atomic weight deliberations of the Karlsruhe Congress in 1860. Basically, a convention of old scientists discussing how massive molecules were and all that fun stuff. Anyway, Cannizzaro brought Avogadro's hypothesis into a discussion about the dilemma of finding the formula for the problem with Gay-Lussac's law of combining volumes, and how the products made were not the correct mass. This convention is what ended with the scientists developing the idea of diatomic atoms and finishing the basis of the mole concept that we all know and love. Thank you for watching and enjoying our presentation on mole concept. Alright everybody, let's all exit through the grey curtain. It's after show party time.
The what curtain?
The grey curtain. It's party time.
That curtain's red. It's a red velvet curtain.
So, Mr. Molesby, how long have you suffered from Daltonism?